All right, we're back with a new game. Name a secant. Okay, so remember, a secant is like shooting an arrow through a balloon. So the secant goes through the circle. So that'd be right here, and you can call it HG or GH. A radius. Now remember, a radius goes from the center out. So you have this right here, CD or DC, or CB or BC. Either one of those work. A point of tangency. Well, remember, a line of tangency just barely touches the circle on the outside. So that would be this line right here. So the point of tangency is where it just touches, and that's A. Name a chord. Now remember, a chord goes from the circle to the circle. Okay, so both dots are on the circle. So EF or FE, but another one, even though it has these arrows, if you mark it just as a segment, HG and GH also work. All right? And technically, not on here, but technically, whoops, a diameter is a chord because it goes from one point of the circle to the other point of the circle. It just happens to go through the center. So, I just said it, the diameter is BD or DB. Find X. All right, so remember, when you have a situation where you have an inscribed angle has its vertex on the circle right there. It's a 2-to-1 situation. So the angle is half the measure of the arc formed by the angle. Find X. Okay, so now remember, when they intersect outside like this, it's a very simple formula. You won't have to memorize this. It'll be on the formula card. It's the big arc minus the small arc. So you take the big arc minus the small arc, divided by 2, equals the angle. So the first thing we need to do is get rid of that 2. So we multiply both sides by 2. Remember, those 2's cancel. We do not distribute inside the parentheses. So that leaves us with 280 minus x equals 160. Now when I subtract 280, I'm going to get careful. I get negative x. Don't lose that because we get negative 120. A lot of people will say x equals negative 120, but you can't have a negative angle. So you must divide by negative 1 and get positive 120. Again, you won't have to memorize this. You just have to be able to do it. Points of tangency. Very simple here. All we do is set this equal to this. 3x plus 2 is equal to 5x minus 4. I like to keep my x's positive, so I'm going to subtract 3x from both sides. Therefore, I'm going to move the number over. So those cancel. That leaves me 2x equals 6. When I divide by 2, I get 3, which you could plug back in and prove. 5 times 3 is 15, minus 4 is 11. 3 times 3 is 9, plus 2 is 11. All right, so in this situation, when you have 2 chords intersect, basically you just take the 2 parts of that chord times each other equal to the 2 parts of that chord times each other. So 9 times 4 equals 2 times x. So that's 2x equals 36. When I divide by 2, I get 18. Okay, if the line is tangent, if n is tangent, find the measure of DCB. So first off, make sure you know what you're getting. You're getting this right here, DCB. Now there's 2 ways to do this problem. I'm going to walk through both ways. When you have the situation, again, it's a 2-to-1 ratio. So if this angle here is 70, that makes this arc 140. Well, if there's 360 degrees in a circle, then 360 minus 140 gives us, oh, I jumped ahead of myself, 220. And that's actually the wrong answer here. I need to fix that because that 110 is the measure of this angle here. Okay, so this should actually be 220. Now, when I say there's two ways to go about it, the other way is to think about the fact that this line here and this chord here are a linear pair. Therefore, if I do 180 minus 70, that gives me the 110 right here. And then I double it to get the arc, 220. All right, find x. All right, so in this case, and again, you won't have to memorize this, you'll have it on the card, but in this case, when they intersect inside, you take the two arcs and add them together and divide by 2. And that will give you 170 divided by 2, which equals 85. Okay, now this one, you have just a tangent line and you have a secant. Because remember, this could keep going like that. Whoops. You know what I meant. All right. So in this situation, we always start with the outside number. It's going to be 3 times these two added together. X plus 3. 3 plus x, same thing. I just like to put the letters first. Equals the tangent squared. So that gives me 3x plus 9 equals 81. I subtract 9. 3x equals 72. And then I divide by 3 and get 24. Now in this situation, it's similar, but we have two secants. So I like to do it this way. I put both outside numbers first, the 5 and the 4. Then I put my parentheses, and I add these two together. Technically, you can write 11 plus 5, or whoops, or you can just write 16. Doesn't matter. And here, x plus 4. So that gives me 5 times 16 equals 4x plus 16. So 5 times 16 is 80. If I subtract 16, I get 64. And then when I divide by 4, I do not get 20. Oops, I meant 16. I had divided the 80 by 4 before subtracting the 16. Silly me. So the answer is 16. All right, find BED. Okay, B. Now remember, we're going towards E to D. All right, so I'll just fill in the numbers first. So right here we have 18. Now notice we have a semicircle here. So if we do 88 plus 18, okay, then we get 106. If we subtract that from 180, that will give us that missing piece there of 74. So we can put 74 in here. Also, we have a semicircle right here. So if we take 180 minus the 18, then that will give us 162. So if we're going from B to E to D, we need to add up 162 plus, this will also be 18 because of vertical angles, plus 88. Okay, so if we add all those together, 162 plus 18, which is 36, plus that 88, that will give us 286. Another way to do it would have been just to add up 74 and 18, this piece, and subtracted it from 360. So there's more than one way to go about these problems. So whatever you're comfortable with. Okay, what is the center of the circle and radius with this equation? So remember, the equation is x minus x1 squared plus y minus y1 squared equals radius squared. So when we have this right here, it's in the right format, it's 7. This is really x minus negative 2, so that means it's 7 negative 2, not positive 2. And then this is r squared, so if we square root that, r is 6. Most common mistake there is to say 7 comma 2. All right, find AED. So we're going from A to E to D. Well, first off, what we have in here is a pentagon. That means there's 5 angles, 5 central angles. 1, 2, 3, 4, 5. Well, there's 360 degrees in a circle. If we divide it by 5, that means each one of these is 72. Okay? Every central angle is 72, which means every arc is 72. So all you have to do is multiply how many pieces you have times 72. So in this case, we're doing 2 pieces. So that's 144. But if, say, we would have done ADC, we would add another 72. If we did ADB, it would have been another 72. Or 360 minus 72. Either way. Determine if BC is tangent to the circle A. So if it is tangent, that means it's a right angle here. So our good friend Pythagoras says, here is my hypotenuse. But the tricky thing is, you think, wait, 9 is too small to be the hypotenuse. You have to remember, this is a radius, this is a radius. This is 7, which means the hypotenuse is 16. That is bigger than the other 2 numbers. That works out. So we do 7 squared plus 13 squared equals 16 squared. In that case, we get 218 and 256. They're not equal, so no, it is not tangent. Even though it looks like a right angle, it's not. Find the values of x and y. When you have a quadrilateral inside a circle, these opposite angles are supplementary, and these are supplementary. So we just do 180 minus those numbers. So x is 89 and y is 155. And that's it.